All right, now we're going to take a few more minutes here and go back to our adjacency and take a closer look at each value from show IP OSPF neighbor, one of the first OSPF troubleshooting commands we'll ever run. And let's go ahead and bring the equipment back up here because we saw something a little odd when we were on router 2 and ran show IP OSPF neighbor. We saw the neighbor ID was either 172.12.23.23.3 or 12.23.3, just depends on which lab we were using, but still the neighbor ID matched the remote Ethernet IP address exactly. But with router 3, whenever we ran show IP OSPF neighbor there, we always saw 2222 for the neighbor ID. So how in the world did we come up with that? I mentioned in one of those videos that I had left router 2's loopback on there from the static labs. And of course we know that address was 2222, but we never enabled OSPF on that interface. We never ran a command that said network 2222 and then an all zeros wildcard mask and etc. We never did that. So why is that value showing up as the OSPF neighbor ID for router 2? Well, that's always going to be the router OSPF ID or RID. That's what we see under neighbor ID. And by default, that is going to be the highest IP address that we have configured on a loopback interface. And I don't use uppercase very often, so if I'm yelling, there's a good reason. This can also be manually configured with the router ID command, and we're going to do that in just a few minutes. We're going to run a lab. And I'll show you how to do that because there's a classic little gotcha in there as well I want you to see on the live equipment. Usually in production networks you're going to set the router ID instead of leaving the RID selection up to the router. Just depends on what the change control, what the format is for your particular network and for your particular company, I should say. But again, by default, that RID is the highest IP address configured on a loopback interface, even if that loopback is not OSPF enabled. More about that in a minute. Now the PRI value, let's bring that back up, and you can see that was 1 for both routers on their particular interfaces, Ethernet 0. This is the OSPF priority of the interface on the remote end of the adjacency. And the default for that is 1. Off the record, CCENT wise, this does have an impact on the DR-BDR election. If you do choose to watch that optional video I showed you on Udemy, the hour-long on-demand video, you'll see it. You'll see me change that, and you'll also see how it impacts the election on a hub and spoke network in particular. Now, state, we saw a couple of different states there, but of course what we finally want is full. And we see DR here, BDR here. Router 2 is saying my neighbor at 23.3 is the DR. So that's the designated router for our Ethernet segment. And then router 3 in turn, as you would expect, is saying, okay, router 2, my neighbor on this particular adjacency, is the BDR for that segment. And if it was not a DR or a BDR, if we had 3 routers on a particular segment, then the others would be DR others. Dead time, we know all about that one. We've seen that in action, and that's the timer that resets when a hello packet is received from the neighbor. Address is the IP address of the neighbor interface, that is, and you could see on router 2 that was the same here because router 3's IP address on the Ethernet 0 interface, 172.23.23.3, is being used as the RID because it's the only interface we have on router 3. Finally, interface, the adjacency was created via this local interface, and that's it. That's all there is to it. Very, very handy command for troubleshooting, and especially you want to watch your states and, of course, your dead times, because if that goes down to 0, if you see a dash here, you've probably got a pretty big issue because the timer hits 0 and then it just goes to a dash. Not something we want to see. Let's talk about that OSPF RID a bit longer because, again, a couple of odd rules for it. The OSPF RID is going to be the numerically highest IP address of all loopback interfaces configured on the router, even if that particular interface is not OSPF enabled. So that's a rule you just have to get used to. It'll be easy points for you on the exam now, but it is the kind of thing when you see a question and you're like, really? You know, could that be it? But I would be prepared to be shown a list of addresses from a router and say, okay, this is the OSPF RID. and it doesn't matter whether it's enabled with OSPF or not. It's going to be the highest IP address of all loopback interfaces. So what is the big deal about this loopback interface anyway? Why is it so important? You're going to see different uses for the loopback as you progress through your studies. I know it's frustrating to be told, hey, this loopback address or loopback interface exists, and I'll tell you why later. One reason, or the reason really, that we use it for the OSPF RID, and one reason that you'll find that it's used by other Cisco router techniques and technologies, is that a physical interface can become available in a number of ways. You know, the actual hardware could go bad, the cable attached to the interface could come loose, anything like that. But the only way that a loopback interface will become unavailable is for someone to manually delete it, or for the entire router to go down, in which case you have bigger problems that you need to be troubleshooting. In turn, a loopback interface's higher level of stability and availability results in fewer SPF recalculations, which results in a more stable network overall. So that's what we're interested in, because when the RID changes, the SPF algorithm has to recalculate, and we don't mind that once in a blue moon, but we don't want recalculations going on all the time. Again, an interface does not have to be OSPF enabled to have its IP address used as the OSPF RID. It just has to be up if it's a loopback and physically up if it's a physical interface. It is very rare, especially in production networks, to have a router running OSPF that does not have at least one loopback interface. It's very, very rare. But if there is no loopback, the highest IP address on the router's physical interfaces will be the RID, and again, you do not have to have the interface be OSPF enabled in order for the address to be used as the RID. I know you are really tired of hearing that now, but you'll thank me on exam day. Let's go back and change the RID then, and we're going to use the router ID command to do that. We're on router 3, so just for lab fun and giggles, we will go ahead and go into router OSPF 1. What if you forget your process number? Let me show you another great troubleshooting command. Great segue, huh? It's router OSPF. And it's going to tell you, show IP OSPF. It's going to tell you what your routing process number is right there without looking at the config. It's also going to give you some other information. If your router was an area border router, that would be indicated in here as well. And again, it's the SPF recalculations that we want to be wary of, because usually when this number continues to increment, there's some kind of problem. Could be a flapping link, and by that I mean a link that goes up for a minute, comes back down for another minute. That kind of thing happens out there, and it's a sign of network instability. So this is a good command to run to check to see how many times your algorithm is run. And if you run it back, if you run it, I don't know, back to back like 5 seconds apart, but if you run it once in the evening, once in the morning, then once in the evening again, and you see this number continue to increment, it could be pointing towards some instability in your network. That algorithm should really not be going off on a regular basis. So let's go back to router OSPF 7. And as you can see, I told you there were a lot of details with OSPF, and we don't even hit them all in the CCNA, believe me. You get a taste of OSPF here in the CCENT, then in the CCNA we give you more details, and in the NP we really go at it. So there is a lot to OSPF. And the command we're looking at right now is router ID and iOS help. iOS help is giving us a blinding glimpse of the obvious here by telling us it is the router ID for this OSPF process. So let's go ahead and run that command. And it's just going to tell you point blank, hey, give me the RID in IP address format. So you can't just put router ID 2 or something like that. So let's say for lab purposes, we want to make it all 33s. And believe it or not, there are no options, especially with OSPF. Sometimes it just seems like there's one option after another. But there's no option here at all. Now, this is very unusual, and also why I wanted to show you the command on live equipment. To make the OSPF RID change take effect, you either have to reload the router or use a command called clear IP OSPF process. And that is going to do exactly what it sounds like. It's going to clear your processes. And in doing so, it tears your existing adjacencies down. Now, if you haven't made any other changes and everything was fine before you did that clear, then your adjacencies should come back up. But it's not the kind of command you want to run at 1 o'clock in the afternoon on a production network, because everything's going to be stopped. The adjacencies are going to be torn down and they have to reform. So since we already know how to reload a router, let's go ahead and run the clear command. And there are no options there, so let's run it there. Now, two interesting things going on here. First off, not only does Chris Bryant not use uppercase very often when he writes something, but Cisco iOS doesn't put it in all caps very often anyway. Reset all OSPF processes, and also notice what the default answer is. The default answer is no. Just with one O, but still the default answer is no. Anytime you're about to do something and the router gives you a prompt and the default answer to the prompt is no, I would step back from the abyss. No, you're not stepping back from the abyss, but I would step back from what you're about to do. Because whenever you see this, and that's not very often at all, what you're about to do is serious. It has serious implications for your network. So for our lab, it's not going to hurt anything, so I will go ahead and put in yes. And you immediately see a message, OSPF adjacency change went from full to down. Let me string that over. But it came right back up. It's on a broadcast segment, not much to do there. So it came back up immediately, but again, some adjacencies are not going to come up that fast, so it's not something you want to do in the middle of a busy day. So again, that's how we run it. Now let's run show IP OSPF. And you can see right up here at the top that the RID has been successfully changed. You can also see the SPF algorithm ran a few times because we dropped our adjacencies and then they had to be brought back up. So seeing something like that, we understand why the algorithm executed. We changed something. But if you see that number regularly incrementing for no reason at all, there's a problem somewhere in your network. Now let's go over to router 2. And now the change has been reflected. There it is, all 33s for all 4 octets. So that is how you change the router ID. It's not something we do on a regular basis, and your company may have a process for that and say, okay, when we add this router in this area, this is what we want the ID to be. That's great, but the important thing is now you know exactly how to do it. Now I mentioned earlier a little something about stub areas, and I'm going to give you a very small taste of that here. Because one of the benefits of running OSPF, as we mentioned very early in our discussion here, is that all of the routers have a similar view of the network. But as we discussed in the static section, there are times that we may not want all of our routers to have a similar and full view of the network. Because this should look very similar, very familiar I should say, to a diagram we looked at earlier. Because we're talking about a stub area. With these 3 routers that are entirely in area 100, if they are sending data anywhere to the rest of the network, it doesn't matter where it's going, the next hop is always that router right there. Well, there's no reason for each of these routers to have some table that has 80 routes in it. There's no reason to have that at all. You just want to have a default route on them and just point them to this hub router and just say, hey, any packets we have to send out, we want to send them to that guy right there, and he'll take care of it from there. Now, the actual configuration of stub and total stubs, that is beyond the CSEN exam, but I want you to see an example of when we might configure one. And it also helps to illustrate a command that you just might see on your exam that we're going to talk about right here and right now. Because again, there's no reason for those 3 routers that are completely in area 100 to have a full routing table. They just need a default route, that's it. Now, if that central router has a default route that it can advertise to the stub routers, that's fantastic. And we can make that happen with the default information originate command. I love that. It's just such a great command, default information originate. Well, what if the central router doesn't have a default route to advertise? You might think, well, we'll just add one on there and then we'll, send that to the stub routers. We actually have another way we can do that with default information originate, and we'll talk about that on the very next video. I'll see you there.